Hello, I would like to present to you my project titled Logistic Regression versus Feed-Forward Neural Network Assessment on example of Advanced Database. Advanced Database has no outliers, has a good feature separation, and equal size of each class instances. Each of the features we can visualize using boxes, histograms, scatter plots, and indeed retrieve some information out of this data. However, even with 4 features, we need to perform the dimensionality reduction, which we can do using principal component analysis. After the principal component analysis was applied, the features ratio preservation resulted into 96%, which is a very high rate. And indeed combined the features into just 2 the principal components. This data was fed into a logistic regression model, which scored to 88% of accuracy. And also the feed-forward neural net was built, which scored to 96.67% of accuracy. For the neural net assessment, I used k-folds cross-validation. Okay, so let's see, let's have a glance to our code. After retrieving the data, I performed some first exploration of it. Even had a tail functions. Then I loaded the data into data frame, pandas data frame, and performed further exploration, like counting the values into species, column, which is our classifier, visualizing it using standard matplotlib and Seaborn for more advanced visualization, as you can see. And then I prepared my data to perform the principal component analysis. So first I separated the features from my classifiers into 2 separate arrays, and I normalized the data content in the array with the features. Well, because it's required before passing into the principal component for the accuracy. And then indeed performed the principal component analysis, which resulted in 2 rows. Okay, then I fed that, I uploaded that, of course, and I fed that to the logistic regression model, which gave indeed 88% of accuracy. After that, I built a Keras sequential neural net model, which contained only 2 layers, 1 input, 1 output layer. And I also evaluated it. There is some still some separation and data preparation in order to feed the neural net. The neural net I feed it with the data which was not transformed by principal component analysis. But for the Y value, I applied the hot encoding matrix. And in the end, when I built the model, trained it, and compiled it, I made the evaluation using the k-folds and scored to 19. The model scored 96% of accuracy using this k-fold. K-fold splits the dataset into 10. I precised it 10. In that case, 10 samples, and then builds the model for each. and then scores the result, summarize the result of each of these 10 models' performance. Then I unfolded the model and just wanted to see when the data started to converge, because in our neural network model, I applied 200 epochs with a batch size of 5. And then I wanted to explore when actually it starts to converge, so I applied only 60 epochs, and we see that indeed our data started to recognize, our model started to recognize the data quite well on the starting from the epoch 42, and in the end we received the same number as applying the number of 200 epochs. So we can also apply a smaller number of epochs in order to train our model. And then I compared the performance of those two models together. So in the end, the performance of the neural network was better. Simple feed-forward network with one input, one output layer. It indeed performed better than the logistic regression machine learning model with the transformed data using principal component analysis.
I hope you enjoyed my video and see you soon.